more simplifying. Remember, the first thing we want to do with these is factor the denominators to see how much they really have in common. P squared minus 1 is a difference of squares, which means it factors into two binomials, one with a plus in it and one with a minus. The p squared would have come from p times p. The 1 would have come from 1 times 1, of course. And then we have 2 over p plus 1. So each of these already contains a p plus 1. There's no need to adjust that. But the first one contains a p minus 1, so the second needs that as well. And if you put it in the denominator, you better put it in the numerator too. So now we have the two of these with the same denominator, p plus 1, p minus 1. In the numerator we have 4. And from the other bit here we have plus 2p. And then we have 2 times negative 1, which is negative 2. Collect like terms, and we'll put these in the right order, so I'll do the p's first and then the numbers. We get 2p, and then 4 take away 2 is 2 over p plus 1, p minus 1. Now, if you give that as your final answer, there will be red ink and disappointment. Do you see why? There's something else we can do with this. After you collect the like terms and get to this point, always take another look at this, see if it can be factored anymore. In this case it can. You can take a 2 out of it, which is not all that exciting. Just leaves you with 2p plus 1. But look at this. This is what we're always hoping will happen. You factor this, you get p plus 1, and now you can cancel it. Great. So now our simplified form, instead of having all this to it, it's simply 2 over p minus 1, which is a heck of a lot better. So that's our fully simplified version. Now, non-permissible values. Please don't go to here to do your non-permissibles. You'll only get one of them and you'll miss something important. You have to do the non-permissible values from the original version of the expression before you've canceled anything. That means you have to go back to here where we have both of these factors and solve each of them. So from here we get p plus 1 must never equal 0, which means p better stay away from negative 1. And from this other factor, p minus 1 must never equal 0, which means p better avoid positive 1 as well. So there's our simplified version, and the non-permissibles are plus or minus 1.